This new feature supports multi-channel robot synchronization for Cinemeric controllers. In this example, we'll show how machine code simulation can execute channels simultaneously for two robots on rails. We'll also show how to add synchronization marks. The Machine Tool view of the Operation Navigator is where we pair the tool with the device and the device with the robot. Tools and devices have a customizable item to specify the target pocket. When there are two robots, we use this item to specify which tool or device goes with which robot. You can now see the target pocket is set to As Mounted. This makes sense because the tool has already been mounted to the quill, so it doesn't need to be changed during simulation. Now let's look at the quill itself. You can see the quill will be mounted in Pocket 2, which is the flange on Robot 2. Note that the channel is assigned. One Cinemeric controller will run both robots. Cinemeric is a good choice of controller because it can handle 30 axes including two robots. Simple play with a tool assembly will move the robot with the tool. First, Robot 1 moves, then Robot 2 moves. The robot display is not synchronized. Now let's look at toolpath-based simulation. Again, Robot 1 moves first, followed by Robot 2. The robot display is not synchronized. For machine code-based simulation, both channels execute simultaneously. The system must run the entire post-processor up front before the simulation will begin. You can display an execution view for each robot. You can now see both robots play simultaneously and are synchronized. Next, we'll add synchronization marks. NX must run the post-processor and machine code simulation for each robot up front so it can determine the relative times between them to attain a synchronized toolpath. What we see here is the same as what we saw for machine code simulation. Both robots play simultaneously and are synchronized. We'll now add a synchronization mark so that the first robot will wait for the slower second robot. Both channels will be affected as shown by the checkboxes. Now we have a sync mark. Dragging the sync mark for the first channel to the beginning will cause the first robot to wait at that mark until the second robot gets to that point. We'll need to recalculate the times. Again, NX must run the post-processor and machine code simulation for each robot. Notice that Robot 1 now waits for Robot 2. When the synchronization mark is hit by Robot 2, Robot 1 will continue.